All right. All right, so that last video clip that you just saw was a shot of the room after school on Wednesdays when we have math club people in here and Step Up and other people just kind of hanging out. So I know it can get chaotic in here, so there's nobody here now. I'm just going to go through some of the things that we've been going through in this new chapter, which is dealing with inequality. So we're going to start off as simple as possible. And that's kind of the idea with all of math, really, is everything builds on one another. So we're going to start off with something as simple as possible. Hopefully it's something that you've kind of seen before, and then we'll slowly add some new stuff. And so you'll see, oh, that builds on the next thing. And it all kind of starts to come together as it all makes sense to you. Hopefully you start having a lot of these aha moments. So what we're doing is inequalities, and inequality is, well, let's look at the name, inequality. So it's not an equation, okay? Equal symbol, it is not equal, okay? So we're not gonna talk about things where values of something are not just one thing. There are a whole range of things. You have probably seen these symbols before. This is the less than sign, okay? So that means something is less than. So I'll give you an example, like 4 is less than 5. Hopefully you're sitting there going, okay, duh, Mr. Jameson, I get it. 4 is less than 5. All right, so what we're going to do, since this is algebra, is do something like this. X is less than, let's say 5 again. And we can talk about the different values x could be. If I just said x equals 5, well, x can only equal 5 here. X is 5, it's very straightforward. When I change that equal sign to an inequality, in this case a less than sign, it's x is less than 5. So what can x be? Well, x could be 4, x could be 3 or 2, or negative 4,000, or any negative number. It could be 0, it could be 4.9, it could be 4.99. It could get really, 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 really close to 5, but it never quite gets to 5. And so what we say in words is x is less than 5. And then there's another way to represent this situation. And what we need is a number line. So you've probably seen a number line back in, I don't know, elementary school at some point. Or maybe, I don't know, maybe kindergarten? I have no idea. I don't remember when I first saw my first number line, but it was an epic day. Okay, so number line, here we go. And on my number line, I always put 0 there, just so I have some frame of reference. So I kind of know where I am. There's 0. Okay, so where would 5 be? Well, this is positive 5, so it would be positive direction is this way. So here's 5. That's all I'm really worried about right now. And now we're going to try to represent the x values on this number line. So what we're going to do is say, okay, all numbers that are less than 5, let's represent somehow on this number line. Well, it would be nice to just highlight all the numbers that are less than 5. And that's kind of what we're going to do. So everything less than 5 we're going to kind of highlight. So we can kind of start shading in, but you can do this business here. So we're just going to try to shade in, and I'm going to shade the arrow too. And in class, I'm constantly asking everyone, why do we put the arrow down there? It's because it goes on forever. Forever and ever and ever. For infinity. Negative infinity in this direction. Positive infinity in this direction. So as we shade, we're shading, and we're getting really, really close to 5. We're getting really close to 5, but we can't equal 5. So x can't equal 5. And the reason x can't equal 5 is because if x were 5, then that would mean that 5 was less than 5. But 5 is 5, so it can't be less than itself. So what we do is, at 5, we put a circle here. And we don't just put any circle, we put an open circle. So there's another teacher here that calls this an open manhole cover. So it's, if you don't know what a manhole is, and some people didn't, I don't know why, but in the streets, you know how there's like those big circles, and sometimes, well, hopefully they're all closed, but that's where like all the sewers are. So this is like an open one, so you would just fall through. You can't get to 5. And I'm going to show you how to change this in this other situation when it would be closed. So this is open. This means, open circle means it's strictly less than or greater than that spot. So we're not including this point. Open circle means we don't include that point. And we're not including the point 5 because we don't want to represent 5 in our solution set. All of our solutions, all of our x values are only these values. All right? If I can do one thing to change this whole problem. What I would do is, if I draw this line here, now this says x is less than or equal to 5, which means it can equal 5. And if it can equal 5, we want to be able to be an x value walking along this number line, and we want to be able to jump onto 5, which means we need a closed manhole cover. So we're going to fill it in. So closed circle means you do include that point. I guess this isn't completely colored in, but you get the idea. Okay, so closed circle means you include it, so that's when it's less than or equal to. So eventually, we're going to come up with more and more number lines. So I'll show you in another example how it gets more and more complicated. All right? Cool. Okay, so the next problem, we're going to step it up a little bit. So now we've got something more. We've got another inequality. All right? Now it's got a different symbol here. We've got, this symbol's a greater than or equal to. So just to review, this is a less than sign, less than or equal to. This is a greater than sign, and a greater than or equal to. All right? So it's probably a review for you. What this says is 2 times x is greater than or equal to the number 12. We want to figure out what are the x values that we're talking about here. What are some possible x values? So before we draw a number line, let's think about this. All right, what are some possible values for x to make this whole statement here true? Statement being 2 times some number is greater than or equal to 12. So let's pick a number. If we pick x equals 1, 2 times 1 is 2, and 2, is that greater than or equal to 12? No, it is not. So x equals 1 will not work. All right, what about 2? Well, 2 is not going to work, or 3 or 4. 2 times 6 is going to be 12, so that is greater than or equal to, because it satisfies the equal to portion of this. So 6 seems to be an important number. What about 7? 7 works because 2 times 7 is 14, and 14 is greater than or equal to 12. Okay, so to solve this algebraically, without the number line, we're going to treat this just like we would if this was an equal sign. And later you're going to see how there is something that is going to be different about this when it's not an equal sign. For now, in this particular problem, we can treat it as if it is. So we're going to divide by 2, right? On both sides, just like we would before. So the 2 over 2 is 1, so that we're left with x is greater than or equal to 12 divided by 2 is 6. And now we're right back to what the other example was. So we've got an inequality statement that says x is greater than or equal to 6. So x has got to be greater than or equal to 6 in this situation. All right? If we draw the number line to represent our answer, which is something that I'll be asking you to do, draw your 0, your number line, get your 0 for frame of reference. Where's 6? 6, let's say it's in the positive area over here. Now at 6, we want to make sure we put a circle and that it's closed because it's an equal to. All right? So we're making it a closed circle, very important there. And then x values that are greater than or equal to 6. So that would be in this direction because this is where 7, 8, and 9 would be. That would satisfy this requirement. So we're going to shade in this direction all the way over to the arrow. It's just some sort of indication. Obviously that's not like great shading, but it's an indication that says, hey, we're talking about these values over here. All of these, and then keep going. Any value that way, from 6 is the lowest one, that's the smallest number, to infinity. So infinity is out here. The way you write an infinity symbol is like sideways 8. Over here is negative infinity. All right? That's how you would do a more complicated one. And you're going to stick with that process for a while, and eventually we'll throw something else in there that'll make it a little bit more confusing. Well, hopefully you'll get it though.